In this video, we're going to find the derivative of a function using implicit differentiation. Let y be defined implicitly by the equation 3 4th root of x plus 2y to the 2/3 equals 75. Use implicit differentiation to find dy dx. So we use implicit differentiation anytime we have x and y on the same side, and we do not have an equation that is y in terms of x. To use it, we're going to take the derivative of the whole equation with respect to x, and that would be 3x to the 1/4. I'm just going to rewrite that radical as an exponent, plus 2y to the 2/3 equals 75. Then I'm going to split this between each term, so that'd be the derivative with respect to x of 3x to the 1/4 plus 2 plus the derivative of 2y to the 2/3 equals the derivative with respect to x of 75. We do the derivative of x with respect to x, and we're just going to take it the same way we normally do. So that'd be 1/4 times 3, which would be 3/4. X, subtract 1 from that, that'd be to the negative 3/4. Plus the derivative of y with respect to x, we're going to start the same way by doing 2/3 times 2, which would be 4/3. Y to the subtract 1 from that, that'd be negative 1/3. But we have to multiply by dy dx here because we're taking the derivative of y with respect to a different variable. So if this was d over dz, we'd say dy dz. And that's equal to derivative of 75 is 0. We're trying to solve for dy dx because that's y prime essentially. So we're going to subtract 3 over 4, x to the negative 3 over 4 to the other side, and we end up with 4/3 y to the negative 1/3 dy dx is equal to negative 3 over 4 x to the negative 3 over 4. Then we're going to divide this across, and we end up with dy dx is equal to negative 3 over 4 x to the negative 3 over 4 over 4/3 y to the negative 1/3. Now when I divide these two fractions, I end up with dy dx is equal to negative 3/4 divided by 4/3. I can rewrite that by saying it's negative 9 over 16. I can move this negative exponent to the bottom, so it'll be x to the 3 over 4 here, and this negative exponent that's in the denominator to the top, which would be y to the 1/3 power. That's the derivative of the above equation.